other people.
Did you see? I know. All right.
Is that where we hear the like?
No, that's when there's like a no volume and then my voice is off from the thing. That's what that noise is. But I don't know what the like. It's super weird. I recorded one and I was playing it back and then I heard the like, and I was like, what is that? And then Sydney thought it was my heartbeat because I hold the microphone right here. Like when I record, I always just hold it like this. But I don't think. I mean, why wouldn't you hear my heartbeat all the time? I don't know. It's only here. All right, a pan of biscuits is removed from an oven at which point in time t equals 0 minutes. The temperature of the biscuits is 100 degrees Celsius. The rate at which the temperature of the biscuits is changing is modeled by this lovely function, b prime of t. Find b prime of 3. Would this be a calculator problem or no calculator problem? Definitely a calculator problem, right? So I would say b prime of 3, and then I would do that on my calculator, right? You don't even have to write this on the AP test. You could just write b prime of 3 equals, and then type it in your calculator. Make sure you put parentheses around that whole thing. Like don't close the parentheses after the. I totally wrote that wrong. Like negative 0.173. What tends to happen is people close that parenthesis and then it messes things up. Don't do it. Don't be like that.
So I didn't even know that there was a U.S. history innovation team.
Well, I just want to say that whole Q&A just made me realize why I shouldn't be at this thing Wednesday night, because mine is not passion project, it's not innovative, just stupid and puzzle.
Well, you're the first person that I looked up and saw, and I was like, we have the math team, and I went to go say science, and then we're hard, and it didn't come out.
Mine is just explaining what I is. So don't feel bad.
I got this.
I did it all by myself.
Okay, yeah.
So.
I did that.
We made a diversity club poster, and Sydney gave a quote that says, "I'm in diversity club because diversity is my jam."
Diversity is my jam.
With an exclamation point.
I added an exclamation point. She said I shouldn't have, but I wasn't crazy.
Diversity is my jam.
I know, she wanted to be there. Diversity is my jam. Sketch the graph of b prime of t on the axis below. Explain in the context of the problem why the graph makes sense. So we're graphing b prime of t, which is this exact function, right? Don't take the derivative again. So go to your y equals, type that in, change your window to the window that's here, and your scale to the scale that's here, like we did yesterday. Grace, I've been forgetting to record for you. I'm sorry. that was like a Mario impression. I'm sorry.
I'm gonna tell you.
Well, the first day we went over the quiz, so I wasn't going to record going over the quiz when you hadn't taken it. And then yesterday, yeah, she remembered that day, or maybe at the end you remembered. But I was like, we're going over the quiz.
I remember, but I was like, hey, should we have been recording then?
And then yesterday I should have recorded, but I just didn't.
Does anybody have their charger for their calculator?
Oh my gosh.
Mackenzie's got them. I'll need to charge mine. It's been like basically almost dead.
It just started yelling. It's really cold, just mind you.
Mine was dead this weekend.
Yeah, I left it in my car last night. Why is it not graphing?
So you just put it like this and then you
And my window is.
I know what scale means now.
I didn't really get it before.
But how do you know?
Why do you know what's a graph?
Oh, you have it in your computer? Yeah.
You don't have a graph?
No, mine won't.
window.
I
My
put
window
it
is
They said it's, yeah.
-6 to 2 and -1 to 11.
Should I have kept my scales at 0?
No, your scale should never be 0.
I know. Well, I
My
know.
scale should be
But like,
1.
I'm just asking what's wrong.
Does it have the tick marks on your graph?
Yeah.
Yeah, I put tick marks.
Mine has a graph. Did you write your equation in the y equals
Yes.
part?
Look.
Oh wait, I put ×3.
So you should do -13.84 e to the negative 0.173x.
Oh, X.
I have that. I don't have my
it times 3.
I did this. I thought the hydrant was
So what's your window? Say hi, my wife.
Just use the window that's here, right? So your x is going to be negative 1 to 11. So negative 2 to 11.
Say I have that.
I did the same thing as you. I thought
Look, you didn't put an x in here. You have negative 1.17. Oh yeah, that's nice. Sorry, my brain's bad.
-6 to
Okay, and then
2.
is there something wrong with my window?
Oh wait, what's my scale?
Your max and your min are mixed up. Minimum should be -6. Max should be 2.
Oh, okay.
I was about to comment how like better I've gotten with my calculator, and I ruined it.
So close.
Ah, you guys are funny.
No, that's hilarious. You're more girls.
Magic Girls, we have 1, 2, 3.
It's gonna take me forever to watch them all.
I just watch what?
Gilmore Girls.
Oh,
I just started it while my kids are sick.
it's
Sort of like that. Do you agree with that?
Yeah.
Explain the context of the problem and why it makes sense. So if this represents the rate at which the temperature is changing.
we didn't put units above.
Uh-oh. We didn't explain the meaning of the value either.
We're so good at that. Did we learn anything yesterday?
Degrees Celsius per minute. So we just took these biscuits out of the oven, and we get that after 3 minutes, the rate is changing by -8 degrees Celsius, which means what's happening?
They're cooling down.
Oh, because we took it out of the oven, right? So explain the meaning. I would say at 3 minutes, biscuits. Biscuits is how do you spell biscuit?
That's
good. I just spelled it wrong too.
Biscuits.
I had to BUS. I was like, what?
Temp is you could say changing at -8 degrees Celsius per minute, or you could say losing 8 degrees Celsius, right? Like or in decreasing by 8 degrees Celsius per minute, right? Like just don't do a double negative. Don't say decreasing at -8. You know what I'm saying? Is changing by, I'm going to say -8.236 degrees Celsius per minute. Something like that. So since we now explain this, I think our graph makes more sense. That if we, it doesn't really show us what's happening here, but from the graph that we can see, what's happening to the rate,
The rate that it's cooling is.
Wouldn't it
Slow down because once it became room temperature, then it's slowly.
So we dropped it.
well, it says graph B prime of t. This is the derivative. I don't like this window.
Maybe the biscuits are like special powers.
Change your window from 0 to 20. Because I feel like our little segment of the graph is
Wait, on the Y?
on the X. Like, so we can look at from like 0 minutes to 20 minutes.
Well, that didn't help much
It's the
more.
same thing.
Oh my gosh. So change your...
Closer and closer to 0 on the x-axis. You know.
It is getting closer and closer to 0. So you said it's getting faster, but it's not actually getting faster, right? Like as this goes up, the rate that it's changing is getting closer to 0 because it's gonna like equal the room temperature at some point. Does that make sense? Like it's changing a lot the first few minutes because it's losing temperature pretty quickly.
And then it just kind of straightens out.
But then as time goes on, the temperature is gonna like reach room temperature, it's all cooling, and it's not gonna change that much.
Reason is my homeboy getting some.
I'm gonna write time. As time passes, the change in temperature gets smaller, closer to 0. Slower, closer to 0. Now it asks, at time equals 10, what is the temperature of the biscuit? So this is where we have to start thinking, no longer can we just always take the derivative. No longer can you just always take the integral. You have to think about what you're doing in the context of the problem. So if this is b prime, and that's the rate of change, and I want the actual time at 10, what am I doing here? The antiderivative from what to what? From 0 to 10 of b prime of t. And I'm actually just going to write b prime of t, because I'm going to type it in my calculator, and I don't need to write it again. I'm just going to write like this. And I have to take into consideration that initial time, right? And that's where we've been just saying, well, that's equal to b of 10 minus b of 0, right? Because we know the initial temperature. The other way to do that is you could just add the initial temperature out front or something, but I feel like this works well. So I'm going to use my calculator for this, and I know that the initial temperature is 100 degrees Celsius, so that's what's going to go right here. But this is what you have to write on your free response to get a point. You would get a point for writing that, and then you're going to get a point for doing the math right. So now this is where we're going to do math 9. See why they give you more time on the calculator for... Oh, this is why we're practicing, Emma. Stop being so negative.
I don't like it.
That's why we're practicing.
Exactly, Grace.
I got negative 65.817. Think about what that means. In the first 10 minutes that the biscuits are out of the oven, it lost 65 degrees. But I want to know what is the temperature after 10 minutes, so I'm going to add 100 to that. And I'm going to get 34.183. And what would be the units on this? Degrees Celsius, which I think are biscuits we could eat. I don't really know my Celsius that well.
32
For, like, the
degrees
only people
Fahrenheit
still use
is
Fahrenheit.
0. So I'm assuming that's like 60 units.
100 degrees Celsius is boiling, right? That's why Celsius is better, because 0 is freezing and 100 is boiling.
I was
So
thinking like
I think that's
32 Fahrenheit.
warm biscuits,
Warm is.
not hot biscuits.
I
Okay.
hope after 10 minutes you can eat them. I think you know what, I eat them.
Oh, you're
soon.
not. I wish you do that.
My husband made chocolate chip cookies this weekend because I've been nagging him because he didn't make any at Christmas time, and he always makes cookies at Christmas time. And so every day I just say, I really wish I had some chocolate chip cookies. So Sunday he finally got up to make some, only he accidentally used baking powder instead of baking soda. And like, he's like, what is wrong with these? They don't look good. And I was like, oh. I'm like, let's look at the recipe. And I was like, maybe the baking soda was expired. He's like, no, baking powder. And I'm like, no, it says baking soda. And he's like, oh, that's what's wrong with these. And I was like, I bet this will be okay. So I ate one right out of the oven that was like lava hot. So hot that I couldn't even taste it. I just tasted the melted chocolate chip. And I was like, I don't think they're bad. He's like, really? And then they cooled down and they're really bad. All right, let's do another one. A cylindrical can of radius 10 millimeters is used to measure rainfall in Stormville. I didn't want to live in Stormville. During the first 5 days of a 60-day period, 3 millimeters of rainfall had been collected. The height of the water in the can is modeled by this function. S of t is measured in millimeters, and t is measured in days, from 5 days to 60 days. The rate at which the height of the water is rising is given by this lovely function. Whew. Find the value of this function. Using correct units, explain the meaning of blah, blah, blah. Calculator? No calculator.
Looks like a calculator.
Calculator, which means if they want you to do this, you're just doing it straight in your calculator. Yes? Go. So this is calculator practice problems.
I didn't know calculator could do so many things.
The first year I taught calculus, we never did integrals or derivatives on the calculator. You'd be glad you got me now.
I was like, oh, how could you do that?
We just didn't do problems like this.
Did anyone pass this exam?
Not good. Not good.
You know, I thought I would never like this calculator. I've always loved these. And then the other day I picked one of these up and I had no idea what I was doing.
I converted you. And remember, we're going 3 decimal places. You can go more if you want, but if you go less, you're wrong. You say 11.1, wrong answer. And then what would our units be on this? Because if we're taking the antiderivative, we should be getting back S of t, right? So this would just be millimeters. And what does that represent in this problem?
From
Yeah, so this represents the amount of rainfall, because if we go back to S of t represents the height of water in the can. Ooh. Oh, no, yeah, that's right. Okay. From day 10 to day 15, 11.159 millimeters of rain was collected, or fell, if you want to say that. Right? And so, explain what this means in the context of the problem shows up on the free response all the time. So that's why there's so much practice with this. At the end of the 60-day period, what is the volume of water that had accumulated in the can? Show your work. Don't be overwhelmed by the word volume there. It just means like how much rain, right? It doesn't really mean like volume. So if I want from the 60-day period, be careful on this. What am I going to do as my bounds?
5 to 6.
Yeah, not 0 to 60 because it starts at day 5. That's tricky, right? And I'm going to say you either have to write this whole function or we can say s prime of t again. And then what's the extra part we have to put in here if we want to know from the beginning? Right? Is that right? My S looks like a 5.
Yeah. Wait, did they give us either one? Oh yeah.
Yeah, during the first 5 days, 3 millimeters were already there. So should we subtract 3 from this? Or add 3 to this?
Wait, hold on.
Because if, see what I'm saying on that? Like, I feel like it's a trick.
3.
But it's already at 3.
Well, you're adding 3 when you add it over. Because you're adding it over S of 60 and then, like,
Yeah.
because, like, this is what it, S of 60 equals is this side. Whenever you add the 3 over, it's going to be on this side.
Yes, but I'm asking if that's what we should be doing in this one. What do you think, Nick? You never say anything.
Well, wouldn't it be, wouldn't it just be free because I have to collect it?
Here's what I'm saying. Here's the can. There's already 3 at day 5. Right? So there's already this much here. And then from 5 to 60 is this much more. So is it asking how much is there just from 5 to 60?
How much water had accumulated?
What is the volume of water that accumulated at the end of the 60-day period?
So I think
But that's not even 60 days, it's only 55 days. I'm just really confused, sorry. I'm just making this more complicated than it is to
Yeah,
be.
look at your key.
That would take work.
You can yell at us, please.
Like, I know we could, like, if we want to say how much water is in the can now, we need to add 3 to this.
Yeah.
I'm just asking if that's what it's asking, and I think it is.
I just wrote 5 right there instead of S.
I know, my S's and 5s look the same. I apologize. So,
Oh, I did the same thing.
No, that second one, that one, the one on the bottom here looks like
5 or S? Like, it's really hard to
The
tell.
top ones are okay. The bottom
Well,
I
this
thought-
this one was okay, and then like once I did this, it was just I guess my brain was messed
I
up.
didn't even notice. I was like, what? Why?
I'll look in a minute. Why
Every
you do
time I
this?
go to do a capital P, it always ends up in an R.
Capital P?
Yeah.
I don't think so,
I
mine.
just follow through.
All right, do this one. The rate at which people enter an auditorium for a concert is modeled by this R of T. For 0 to 2 hours. R of T is measured in people per hour. VIP tickets were sold to 100 people who are already in the auditorium when the doors open at time equals 0 for general admission tickets to enter. The door closes and the concert begins at time equals 2. If all the VIP ticket holders stayed for the start of the concert, how many people are in the auditorium when the concert begins?
Jesus.
What do you do?
Well, do everything plus 100%.
Again, it's a rate, so even though this isn't written as a derivative, the word rate means it's a derivative, right? So if we want to go backwards and find the actual number of people, we're going to do the integral. And what's our value going to be? 0 to 2. And again, this is where, when I'm using my calculator, I write this on my free response paper instead of writing all that out and maybe messing up. But I have to take into consideration the VIP people, right? So that's why we do R of 2 minus R of 0. That was a good feature. I would have it out already.
I feel like all people teach me to work with parents. I think
I thought you were gonna say I think all the good teachers are good. Oh my gosh.
Wow.
How much confidence you have? I'm struggling in my life right now.
All the good people are struggling too.
Yeah. You're one of the good ones.
You know, if you weren't struggling, that means you wouldn't care.
I am struggling and I don't care.
You do care.
Okay.
What'd you get? Are you done yet?
1,080.
1,080? And that's with adding the 100? I'm just asking.
What was that?
Done. All right, here you go. Work on this. And there's no new video tonight. And so this is only one page, right? Which means after you get finished, you can even look at some free response and get a head start. But that's what we're going to do tomorrow. Four free responses that you should practice. Okay, but